Okay, this is the last part of your final. This is setup help for you so that you can complete this last page. So let's get cracking. Ray Guy, a former punter for the Oakland Raiders and NFL Hall of Fame member, kicks a football in a game versus Dallas Cowboys. The ball leaves his foot with a velocity of 88 feet per second at an angle of 30 degrees above the horizontal, and he kicks the ball 4 feet off the ground. So if you know anything about punting, you hold the ball up and your foot goes up and get it. So the ball was actually off the ground when he kicked it. Find the time the ball is in the air. Well, let's come up with a set of equations first. So let's see if we can have a set of equations that govern this. So x with regards to t is equal to, my initial velocity is 88 feet per second times the cosine of the angle, which is 30 degrees times t. That's my x1. And my y value, y of t, is equal to negative 1/2 the gravitational constant for feet per second is 32. So again, that's negative 16 t squared. Plus the initial velocity was 88 times the sine of the angle, which is 30t, plus my start height, he kicked it 4 feet off the ground. Those two equations are going to govern what we do here today. Okay, find the time the ball is in the air. Well, the time the ball is in the air is how long does it take for your y value to reach 0. 0 equals negative 16 t squared plus 88 times the sine of 30t plus 4. You go through that problem, you can use whatever method you want to solve that quadratic, and you pick the positive one, and that's your time. That's your time. If the ball is kicked from the Bears' 20-yard line and is aimed straight downfield, where does it land? So I do have a time value now, and my time value is really what I'm going to get when I know how long it's going to hit the air. So I want to know how far horizontally it went. So I'm going to use my x of t equation. I'm going to set 88 times the cosine of 30 times whatever you get for that time value. You're going to plug that in there. Plug that in right there. And where does it land? I mean, there's ways of doing this. You can say like at the 10-yard line or at the 17-yard line or whatever. But let's just say how far. Instead of where does it land, let's say how far does it go? It go, and let's make it how far does it go, and whatever our label is here, let's use the label, that's yards. Okay, so 20-yard line, I'm not even going to worry about how far does it go. All of our other stuff here is in feet per second, so let's just say it in feet. It went 528 feet or whatever number of feet it went. Let's use that. Let's just plug that number in, and that'll be the answer. That'll take care of some of your problems with I don't understand football. Okay, C, find the max height of the ball. Again, still a set of equations. Find the max height of the ball. The max height is the vertex, negative b over 2a, and then you're going to plug it in. So you're going to go negative b is negative 88 times the sine of 30, all over 2 times the a value, which is negative 16. You're going to find a value here, and that value is really how long it took to get to the max height. So then you take that t value, and if you want to find out how high it went, you plug that t value into the y value, into the y equation for the t's, and whatever you get out of that is how high it went. The first number, how long it took to get to the height. The second number, when you plug it in, is how high it went. That'll be there. How fast was the ball traveling vertically when it hits the ground? How fast was the ball traveling horizontally when it hits the ground? What is the speed and what is the angle? And here is these two problems. They are the problems that have to do with the calculus that we've been working on. I'm going to plot this up here. Maybe I can see most of it. Okay. How fast was the ball traveling vertically when it hits the ground? Well, you got to take your vertical component, which is your y, and you got to find the derivative of that. And I have described this in an earlier video, but there is a shortcut to finding that. Y of t equals negative 16 t squared plus 88 times the sine of 30t plus 4. Okay? And what we're doing here is we're finding the derivative of y with respect to t. So we call it dy dt, the derivative of y with respect to t. And the shortcut was you take your exponent, whatever the exponent is of the variable, you pull it out in front and you multiply it by the constant that was there. Then you drop your exponent by 1. I'm going to take this exponent, I'm going to multiply it by negative 16, and I get negative 32. And then that t squared drops by 1 and becomes t plus. I take t to the first, I pull it out in front, and I multiply it by that. 88 times the sine of 30. And then I drop t, and I make it t to the 0 power, which is 1. Anything to the 0 power is 1. So t to the 0 I could have here, but I don't really need to have it there because that is 1. Plus 4 t to the 0. And I take the 0 and I pull it out in front. I multiply 4 times 0 and I take 0, and then that'll be t to the negative 1. 0 times t to the negative 1 is gone. It's just 0. Turns out the derivative of a constant is 0, which I don't need. And that is the derivative of your vertical function. And what this tells you is how fast something is traveling at a specific time. Well, up above what we found, I think, let me see, find the time the ball is in the air. We actually found a number for how long the ball was in the air. When we set this equal to 0, we found that t value. And whatever you got for that t value when it hits the ground, I think it's letter A, when it hits the ground, you're going to take that t value and you're going to plug it in right there for that t. And that's how long that ball was in the air. Okay, you plug the t value. T it takes to hit ground. Whatever that was, you take it, you plug it in there, and you have it. How fast was the ball traveling horizontally? Dx dt, derivative of x with respect to time. Well, let's go like this. X of t is 88 times the cosine of 30t, and we're doing dx dt. Okay, so this is t to the first. I take that, I pull it out in front, I multiply it. I get 88 cosine of 30, and that's t to the 0, which is 1. So dx dt is 88 cosine of 30, which basically means there's no t value. It doesn't matter what time it is. Your horizontal component is the answer for that. Okay, now I'm going to label this A, and I'm going to label this part right here, I'm going to label that B. And there's a reason I'm doing that. So you can label that, well, you know what, let's use theirs. There's D and E are the two letters. So we'll use theirs. That's letter D and that's letter E. And the reason I'm doing that is because whatever you got for those two answers are what you're going to use to do the final piece. And the final piece is this. What is the speed of the ball when it hits the ground? And what is the angle that the ball strikes the ground at? So I'm going to draw a right triangle here. And I want to know that speed of impact. Well, the speed of impact, D was your vertical component. That's your D value. So you're going to plug that right in there. And E was your horizontal component right there. And that's a right triangle formed from that vertical component to horizontal component. And this is letter F. What you're going to do is you're going to go d squared plus e squared equals this one squared. You're going to use the Pythagorean theorem with those two numbers from D and E to do this problem. Likewise, at what angle does it strike the ground? There's my angle theta. I wonder what that theta is. Well, you have a D component and you have an E component, and it's a right triangle. And we simply use trig. That's opposite adjacent. So we do the tangent of theta is equal to whatever your D component is divided by your E component, and my theta will equal tangent to the negative 1 of D over E. And what I would probably do here is I know the D component here will be negative. Now when you square the D component negative, the negative will actually go away. But I wouldn't worry about that negative when I do this. I would take the positive value of the D component and use that formula, and boom, find your G, and you can write it down and enter it from there. So that should be the end of your test. Good luck. You can enter those numbers and hopefully do well.